This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support. Hello and welcome to episode 129 of Linux Dev Time. I'm Joe.
I'm Monolith.
I'm Kevin.
I'm Andy.
And I'm Allan.
Good to talk to you all again, and welcome back, Allan.
Thank you.
People may know you from 2.5 Admins, where we have talked quite a lot about Bcash FS and the developer Kent Overstreet and the issues he's had with Linus and the kernel generally. And we were talking off air about this and thought it might actually be good to talk about it on this show.
Yeah, especially about just kind of how release engineering works and how to maintain a stable branch of your software in addition to the development branch instead of just everybody gets whatever's on my laptop.
Yeah, so it's looking like Bcash FS is going to get kicked out of the kernel. We haven't got full confirmation of that yet, but it very much looks like that's going to happen. But even if it doesn't, things have not gone well since it got added to the kernel. Allan, maybe you could give us a brief overview of what went wrong.
Yeah, so the biggest problem seems to be that every time there's a bug or an issue reported in Bcash FS, this generally happens during the Linux kernel release cycle, right? So the Linux kernel will bring in a newer version of Bcash FS and do a release candidate, and that people start testing that, and then they report a problem. So the developers at Bcash FS will make a new fix for that, but they will make it in their one branch of Bcash FS that they have and basically do a new release mixed in with all the other stuff they've been working on in the meantime, and then try to force that into the release candidate on the Linux side. Basically not having a way to release just the fix on top of the previous release as like a point release, but just saying, oh, you have to have the whole new version with all the new features and new bugs. And on more than one occasion, that's resulted in a feature that wasn't there in the earlier thing showing up and then introducing a bug that wasn't there. And when you do that during the release cycle, when you're supposed to be stabilizing the software, not adding even more changes that are unrelated to things you're trying to fix, it really makes the release process for Linux a lot more difficult, and that results in Linus getting shouty.
Yeah, and that's the release candidate process for Linux, right? Is that you're not supposed to do anything other than bug fixes during that kind of freeze period, right?
Exactly. And Bcash FS basically doesn't have a branching scheme where they can easily just fix a bug in what version Linux was already shipping. And that's been most of the source of the tension, it seems.
That release strategy makes sense, I think, for the GitHub project that you release open to the world, especially when it's like a one-man project or something. But that seems ill-advised for something going into the Linux kernel. So was this release strategy, like, has that always been the case with Bcash FS? Or like, is this a new thing that they've started doing post some point? Because that seems like that would be a blocker to even get into the kernel.
Yeah, I would have expected so. I don't know if they've ever had a more traditional release schedule, or if it's just always been, we'll cut releases every time we need to fix something kind of thing. But really, to your point, yeah, like, especially if it's going in something like the Linux kernel that has LTS versions where they're going to maintain that version for a long time, you have to be in sync with the components so that if you're supporting that release of Linux for the next 2 years or more, like if you think of like a Ubuntu LTS, then you have to be able to apply fixes to it without bringing every new feature. Otherwise, it's not a long-term support release, right? You're not getting the stability of knowing that when I'm updating, all I'm getting are bug fixes. I'm not getting new features that might introduce new problems. And yes, for especially, solo projects or like websites and a lot of things, yes, just having kind of a rolling release kind of scheme maybe makes sense. But when you're deep infrastructure like a file system or the kernel or a file system in the kernel, you really have to be able to support all the versions you've released and have EOL dates for them and keep your promise that you will keep maintaining that version for whatever the lifetime of that branch is.
We should be fair to the project, right? Because this was an experimental feature, right? So it doesn't have the same level of stability guarantees as, say, ext4 or something like that.
Maybe, but those stability guarantees are about ABIs and so on. It's not just, in order to get the bug fix for the known issue, you have to ingest this second unfinished feature. Like that just is really bad kind of branch management in Git, where each feature should be developed in its own branch and then merged into the development branch when it's ready or whatever. But you also need to tag the previous releases and be able to, cherry pick just the bug fix onto that older branch, which might mean writing a slightly different version of the fix because some newer other work you did isn't actually in the old branch yet, rather than trying to just constantly force people on kind of a death march upgrade cycle of using newer versions of the software with more and more risk each time.
But there are different phases of a project, right? So like there's a phase of a project where the time spent backporting fixes is wasted time or is not worth it compared with making forward progress, right? It feels to me like it's a mismatch between like perceptions of what stage the project should be at when it's part of the kernel that seems like at the core of this.
Well, I think part of that was Bcash FS felt it was stable enough to be included in the kernel, and then maybe it wasn't. And I understand that, yes, backporting stuff has a cost, but if you want people to be able to use it and deploy it long term, you have to be able to meet their requirements for that. And so, yes, maybe it is just too early, but I think if Bcash FS gets kicked out of the kernel, it'll have a much harder time making the case to get back in. Like the bar is going to be a lot higher, and they probably should have addressed that sooner.
I think some of this discussion at least feels a little bit beside the point to me, because the Linux kernel has a process for coming up with releases, for bumping major minor patch versions, etc. If the project's not going to adhere to that, they shouldn't be in the kernel. If they want to be in the kernel, they should follow the established patterns.
Yeah, if part of being part of the kernel is that you need to fix bugs during the release candidate period, then I totally agree. Then you need to fix bugs in the way that you're required to do it as part of that process in that community.
Yeah, and I thought maybe that would be the useful part to talk about is just like how you actually do the Git branch management to maintain both an old version and the development version of your software. Like if you are a solo developer and your project has matured to the point where you want to keep having the version that people are using and be able to release bug fixes for it, while at the same time maybe undertaking a larger project to revamp part of it. Especially, every developers have some level of second system syndrome where they want to redo everything from scratch over again, right? I know so much more now. And so, a big part of that is being able to maintain those two different branches and being able to, Git makes it a lot easier with things like Git cherry pick versus if you've ever had to use like SVN merge to try to bring a change from the development branch back into a topic branch. But a lot of it requires you to kind of think of these things ahead of time, right? To make tags and branches for your releases and to kind of structure your code and even just your commits in the way where you'll be able to take this change and not that change back to a different branch. And Git makes that a lot easier, but if you're not used to it or you don't understand why you would want to do it that way, right? Why you want each Git commit to be kind of a separate atomic thing so that you can say, I want these two commits, but not the next one, where, I made a change that isn't going to be compatible. And how with Git, you don't have to think of all that before time, right? If you've written the changes, you can use git add-p to kind of cherry pick individual bits of a patch. And also with the history rewriting, even if you check in your work in progress commits and stuff as you go and then restructure it at the end, all of that is possible with Git, but you really have to have a plan for how you're going to maintain these releases. And also, you probably want to think about how long are you willing to guarantee to do that. Like the FreeBSD project that I'm most familiar with in their release engineering, it got to the point where they were supporting too many branches at once. And it meant that the really old ones weren't necessarily living up to the promise of, we'll make sure to get the updates to you quickly and so on. And so instead of saying, once we release something, we'll support it for a year and the even ones we'll do for 2 years or something like that, they switched to a model of when we release 13.4, we'll continue to support 13.3 for 3 months to give you a chance to upgrade. But after that, it's on you for not having upgraded to the newer point release, because that point release is just, small features and bug fixes. It's not meant to be anything that's going to be backwards incompatible. Whereas with the major releases, right, when the big number gets changed from, say, 13 to 14, that stable branch is guaranteed for 5 years, that they're going to continue to make the point releases on it, and you'll be able to have compatible software for 5 years at a time. And that gives you a much bigger window to play with, but at the same time, trying to decide how long you're willing to support things for. And some of that also, depending on your project, could be out of your control. One of the things that's kind of handcuffed FreeBSD at times is the end of life of versions of OpenSSL. And so, if OpenSSL is not going to support version 1.x anymore, then the FreeBSD versions that have that we can't guarantee support any longer than OpenSSL does. And so there can be other factors. And, in this case, it seems like Bcash FS maybe should have modeled their release cadence closer to the known release cadence of Linux to try to match up and make sure they have their release finished and polished ahead of the start of the release candidate and aim their next one to be for the next release candidate. But in between, still be able to backport stuff because they maintained both that separate branch and the commit hygiene to be able to cherry pick the changes that are bug fixes separate from features. Instead of, we've all seen commits to a repo that's like, oh, I fixed this bug and added this other feature all in one commit. And you really don't want to do that if you want to be able to kind of surgically pull things into other branches.
Yeah, I don't think it's the case with the Bcash FS developers, or at least I'm assuming it's not, that something like that is because they don't know Git as well or the underlying model. I'm assuming that's not the case. These are probably well-seasoned developers. But we've mentioned it in previous podcasts before, previous episodes, that learning Git at a deeper level than I just git commit -am with a message, and that's all I really ever do. But learning it at a deeper level of how the branches work, how the tags work, what's the underlying structure, how can I commit a partial, like Allan just mentioned, where you have git add -p to only select parts of your staging area. What is the staging area? All these different things. And if you learn that at a more fundamental level, it almost opens up like superpowers as a developer, because you can have more intentional history. You can do all kinds of things with your code that allow you to do these types of things, this type of release engineering, which I actually like that term, release engineering, because it calls out the fact that these things take some thought and upfront design, not only to how you're going to make the commits and make the structure, but also like how are you going to set up the code so that you can make these changes somewhat easily for old branches or old tags and continue to support those older versions for whatever your version support history is, and continue to make new features on the latest main or whatever that is, right? But how you can continue to release new features, but not shoehorn yourself into an area where you can't even fix a bug because that bug fix would require pulling in a new feature from main.
The fundamental mechanism that's needed here is actually really simple, right? It's basically when you're giving the code to someone else, so you could call that a release, or it might be preparing for a release candidate or whatever it is, you need to make a git tag so that you can get back to that point if you ever need to make changes on top of that instead of on top of your latest thing, right? So you need to have a git tag for your release, and then you need to be ready to have a branch off that tag or off the same commit as that tag where you put extra commits that are just the little bits that need fixing in the code that you've given to someone else, and not just like whatever mess you're working on at the moment.
But to your point, it's building on top of that with when you're doing your commits to main, that you're not doing just, git commit -a, and that you're separating out the bug fixes from the not bug fixes so that you can use git cherry pick to just pull those commits from main into that branch.
And sometimes it's also, you find a bug, you also have to go back through all of your previously supported versions and find out, is this bug actually active in those previous versions too? And then if yes for some, if no for others, you can go back and then you can actually have a strategy of, all right, well, how can I fix it either across all branches, or how can I fix it for these ones in this way or this one in this other way? But you end up having to make multiple commits, sometimes multiple releases, new releases, right, for your older supported versions. And it takes thought and release engineering. It takes some upfront thinking about this before you just go in and fix it on main and call it a day.
But yeah, I think stuff like doing really good commits is great from a lot of points of view, and it really helps make this process easier. But fundamentally, it's actually just making your life easier, right? If there's a bug fix that needs to go into a release and you have to dig through some horrible commits in order to find the bit that you need to apply to the release branch, well, that's your fault, and you can still do it if you've got a release branch, and you can't if you haven't.
It depends, too, on what sort of merge strategy you use, whether you use like a squash and rebase for atomic style commits, or you use a merge strategy. Like there's all kinds of different ways that Git will let you merge in branches into a main branch or trunk branch. But which one of those you pick can also have ramifications down the line for how you maintain older branches, how you cherry pick out commits from other branches into older releases. Like there's all kinds of things that take thought when you are planning out how long can you support something and how far back and how would you maintain that.
I mean, my policy is I don't want to see any merges in my real history.
FreeBSD and OpenZFS are the same, where it's always rebase. So you get a nice clean commit history. And in general, we'd rather see a series of commits come in at once rather than a squash, just because if you broke them up, there was probably a reason for it. If there's a fix up, yes, squash that. But if you have the thing and then the tests and some other thing all separate, or hey, before I made these changes, I did this other commit where I rewrote all the documentation, or I fixed the name, I renamed a bunch of variables to make things easier. If you have that as a separate commit that we can choose not to cherry pick back to the old branch, then I can still get the functionality of your fix, but without the unrelated changes.
Absolutely. And also another different variation, but another thing that I love to see is, in a pull request or something like that, is a bunch of commits that make everything ready. And then the final commit that's like a one-line change that just does the change because you've prepared everything so well.
Thinking about this idea of supporting multiple releases going back in time makes me think about canonical and Ubuntu releases and snaps. And I know it's not quite what we were talking about, but if you are supporting a distro for 12 years, which Canonical will do if you pay them, that's one of the reasons why they are so big on snaps, because that solves the problem of supporting applications going way back to old versions of Ubuntu. And people like to shit on snaps quite a lot, but that is a very good strategy, I feel, like especially for really complicated things like browsers. Stick it in a kind of containerized application, and you then don't really have to worry too much about supporting it for years and years to come.
But that's an interesting point that you're making, right? What this does is it makes it easy for Ubuntu to keep supporting an old version of Ubuntu, but they're not actually supporting an old version of your apps, right? They're saying you can get the latest app on this old thing, but if you actually need the old app supported because something changed or something, you need some guarantees, you haven't got that available, I don't think.
Yeah, and that's the difference with different support models. For example, on FreeBSD, there's binary compatibility. So if you're on any version of FreeBSD 14 and you have a binary that worked, it will keep working on all the other 14s, but there's no guarantee that 15 or 13 will work with that binary. It might need to be compiled differently because the interfaces might have changed or whatever. But also, the separation between what is the operating system and what is the applications on FreeBSD means the operating system is guaranteed for 5 years, but the applications, you get the newest ones by default once a quarter, or optionally like every 3 days, there's a new set of applications. So you can always have the latest applications. And their long-term support does not extend to anything that's not part of the operating system, right? Like any applications you decide to install on the OS after you install the OS, those are your fault. The support policy is whatever upstream, right? The version of PHP, instead of having the Red Hat-like thing where you're stuck in a version of PHP that PHP hasn't supported for a couple of years, you just get whatever the newest versions of PHP are. And you have to deal with the fact that that might mean that you have to upgrade your app because PHP 7 isn't supported anymore. You have to be using 8.3 and your PHP app needs to change. And that maybe doesn't make the LTS as strong as something like a Red Hat where you're guaranteed they're going to keep supporting, you made the box once and you don't have to touch it for years. But you can different distros kind of pick and choose which parts they want to cover in their support policy.
And I think it's an interesting comparison there. Like PHP is something that I would like, if I could have it, I would like a long support for, but something like Firefox, I'm pretty happy to just have whatever the latest Firefox is on top of some old operating system.
Yeah, and then there's some distros like Fedora that try to do things like, I think it was called modules, where certain types of packages you could do a kind of a hybrid approach where you can select a channel and get newer versions of it. I think like NPM or PHP were things that you could get newer versions of, but on an older OS. So there's been all kinds of different approaches to that. But I think when we're talking about a programming project, whether it be binary, library, doesn't really matter, we can also run into sort of the same issue as a distro does, but with the actual dependencies that you take on, especially in some of the newer languages like Python or Rust or Go that lean a little bit more heavily on pulling in third-party dependencies. And your support strategy needs to also consider those dependencies that you rely on. And we touched on that a little bit earlier, but if your dependency only pulls in new features and only has, one version that they support, you're either stuck on that version or you can't pull down new fixes of that, or you have to vendor it and support it yourself. You're now writing the code for that dependency. So taking on new dependencies when you have these older releases that you have to support takes even more thought up front, because you have to decide, is this a dependency that I can support myself if need be? What is their release strategy and support cycle? There's all kinds of things that go into that as well.
Yeah, and we saw a lot of that when OpenSSL changed to version 1 and then version 3, and there were kind of ABI changes that meant the application could only support one or the other at a time. And that kind of changeover period was very painful for a lot of applications trying to maintain, a version that would work with the SSL included in this distro, whereas other distros had made the switch. And it can get really fraught. And yeah, like we've seen a bunch of problems when we're trying to help customers update things, whether they be in Node or Rust, where it's like, oh, there's security fixes, but they're only in this newer version of the crate or whatever. And so you have to kind of take that, even though it includes API changes, that mean you have to change the code in your application to call the dependency in the new way. And you kind of really don't have a choice unless you vendor in the old version and then you're responsible for fixing it. And everything's kind of a trade-off. And it seems that a lot of places are getting away from the older model of having semantically version releases and the kind of older release engineering for a little bit more of the, move fast and break things. And there's some advantages to that, but I think a little bit of the art of thinking about it and knowing what those steps are is maybe doesn't get taught in school anymore. And people are not as aware of what goes into deciding what features go in the next release versus what stays in the trunk branch.
And it must help having a proper team, right? We're supposed to be plugging Klara a bit. That's kind of why you're here, ultimately, your company, Allan. Having that company and having a proper team to support these releases surely must be easier than being one person full-time with a couple of volunteers here and there.
Yeah, and a lot of what we do is the interface between all of those parties. So working with the other vendors to understand what their support policy is going to be for the library you want to depend on. Or you've decided that you have to vendor this library and now there's a new security fix for the new version and you need someone to backport it to the version you vendored, and then having a team of people that are up for that task can really make the difference between we're able to maintain the security of our version of the software versus we're either going to have to do a scrambled forced upgrade to the new version and hope we don't break anything else and do a release, or we're going to sit here and be vulnerable until we get around to it.
Yeah, and I think it's very hard to take in quite the responsibility you take on when you take on a dependency, right? Fundamentally what you're saying is either the maintainer's going to do what I want, or I'm going to either have to remove this dependency or somehow vendor it or fix it myself.
Basically fork it and make it my own thing, which is not what anybody ever actually wants to do, but sometimes it's your only choice.
In this world where hundreds of dependencies are available to you at a single command at the command line, it can be easy to forget what you're taking on when you do that.
Yeah, and then you get a whole new set of wrinkles in the system when you look at some of the stuff the EU is doing around who's responsible for making sure software doesn't have vulnerabilities and so on. And it's like, how much liability are you taking on when you vendor something or just use something as a dependency? But you don't want to swing too far back to the other side of, not invented here. If I didn't write the code, it can't come in. And there's a useful middle ground, but it can be really hard to judge that, or just to have the experience of having done release engineering for larger software before to know what things to watch out for, how to plan, how to make up a support policy. Or even just to, hey, we have a bunch of dependencies. We need someone to go through and look at all of these dependencies and figure out what their support policies are and kind of like how that overlays on ours and where the risks are.
Yeah, we've had stuff like that at places I've worked where whenever you want to take on a new dependency, they get somewhat vendored through kind of like a package cache sort of thing where we pull all of the packages or the crates or the libraries, whatever it is for whatever language, through some sort of local repository. And when you want to add a new one to that, you have to go through this whole process of like, do they have a release strategy? Do they have a support cycle? Like there's all these different things that go into it, not just are they experts or do they know the thing that they're doing, like cryptography, right? Are they actually crypto experts that know what they're doing here? So all of those things are things that should be considered when you are bringing in a new dependency.
So old-fashioned, Kevin.
Say your project releases version 1.3 and you find there's an issue in 1.2. what are the steps for getting whatever the fix might be from main into 1.2.1?
So generally that's going to be you figure out what the problem was and make a fix and commit that to your main branch. And then ideally it's not that different than your 1.3. So then you go to the 1.3 branch and you git cherry pick maybe -x, that commit into the 1.3. Because there's not a lot of diff, it doesn't have any merge conflicts and you're good and you can release 1.3.1. But when you want to do 1.2.1, there's a lot more delta. And so when you try to cherry pick, again, likely from main, but possibly from the other one, depending on how you stagger your branches, it's likely you're going to hit a merge conflict because a lot of the code around what you just fixed has changed because maybe you wrote a bunch of new code or whatever. And so you're going to have to kind of solve that merge conflict and figure it out, or possibly just write a different fix for the older branch, depending on how much has changed. And like in Kevin's example earlier, maybe the 1.0 branch never had the feature that had the bug, and so there's nothing to do. But with 1.1, in the easy case, you're cherry picking the commit from main into the release branch, and there's no merge conflicts and everybody's happy, and you can just, push that and then go to GitHub and click release. But you might be solving merge conflicts, or it might be write the fix a second time for this almost different version of the code.
It's worth pointing out here, like, maybe it's obvious to people these days, we don't even think about it, but if you're going to check that your old release actually still works with the fix in it, you're going to need all your tests and all your build tools to work properly in that old version. So as much information as you can, if it's checked into Git, like all the stuff about what build tools you're using, all your tests are in sync with it. If all of that is in Git as well, so when you just switch to the release branch, it's updated to or backdated to the old versions and everything just still works, you're golden. But if you've got some external test suite that is now incompatible with your old version, things get a lot harder to check it really works.
And then that can also be like if you are testing across different distros and different libcs and there's all kinds of variables that go into that too.
But it can definitely be one of the advantages, kind of a mono repo of having your tests live beside the code rather than in their own repo, just because then they're versioned in sync. Maybe you can manually create the right tags and so on in the other repo, but sometimes a mono repo is a much nicer solution.
I think it all boils down to, as well, though, still knowing Git really well so that you know what your options are. As in, if I were to take a very silly analogy and say, like, a car, I know that this is the steering wheel. I know this is the go faster, the gas pedal or the brake. I know what all the different options are. I know that there's not a, like, take off and jump 20 feet in the air button, right? So that would never be an option. I'm not going to drive up to some blockade and be like, I can just jump over, because I know that there's no jump over the blockade button. But knowing what is possible in Git really helps you divine out these types of strategies and know what you can do, and conversely what you can't do, like what is possible and what's not.
Surely you just add, please make this work for all my old versions to the end of the prompt.
Do we have to end every episode now with an AI troll?
I think we have to, yeah. Well, it's been absolutely great having you, Allan, as usual. You should plug Klara properly. I can't believe we got all the way through this episode without using the last letter of the alphabet.
Yeah, so if you're trying to maintain software, or especially if you're building a product or appliance that uses open source software and you want to either help maintain the upstream version of it so that it maybe will be able to do the support lifecycle that you need, or that you have more input on how the community works, or you are vendoring things and need to help maintain them, or whatever it might be. If you need services around open source software, please reach out to Klara. We do more than just FreeBSD and ZFS. And in particular, we really are connected to the community to make the maintaining not just keep it working for us, but try to share it for everyone and kind of equally spread out the burden of keeping all the software that we all depend on working.
Right, well, I'll put a link to Klara in the show notes. We'll be back in a couple of weeks. Until then, I've been Joe.
I've been Amalith.
I've been Kevin.
I've been Andy.
And I'm always Allan.
See you later.